1823 for CS6310, assignment 6. So today we're going to be demoing the UI for the new and improved lawnmower cutting project. So before we only had one lawnmower and its responsibility was to cut the grass with craters. So we're going to show you the brand new improved. So to see that, we run this command, and this will read a file that has the preliminary lawn specifications. So currently it's loading up the UI, but this file says is that it's a lawn 10 by 8 with 3 lawnmowers with 5 craters and 2 puppies. So the puppies we haven't seen before, but we'll explain soon. So here is the new UI. So before we had only had one lawnmower and craters, so the lawnmower was going by itself around the lawn and cutting grass. But now that we have 3 lawnmowers, we need a way for them to talk to one another, and that's where the lawnmower database comes in. And this is where anytime the lawnmower moves or does a scan, it will update the mower database and allow other databases to use that data and determine its next move. And then before we had these craters, which are obstacles, and the lawnmower had to avoid the craters and the fence, otherwise they would crash. However, now we have puppies, and these puppies will randomly move once in a while every time they're pulled. So, however, when a mower hits a puppy, it's not going to crash, it's going to just stall for a couple of turns. So, to start this off, we will hit this next button that will pull this current object. So right now we see it's turn 1. There's already 3 grasses cut because all lawn mowers automatically cut their first grass, and we have 72 to go. So as we hit next, we see that the first lawnmower does a scan, and the scan result is shown from a north and clockwise direction. So a crater, grass, 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 grass. So that makes sense. So for mower 2, we expect all grass. Then we hit next. Yes, we see a mower 2 has scanned on all grass. In mower 3, we just see 5 grasses, then a crater, then 2 more grasses. So yes, we see that. So now the puppy 1. So a puppy can either move or stay on its current position. So it's based on a probability percentage. So this 60 right here is a 60% chance that the puppy will stay on its lawn. And this is unified for all puppies. So we hit next, we see that the first puppy is staying. It's okay because it's more likely to stay than not. And puppy 2 is also staying. So since these 5 objects are the ones that are getting pulled, after 1 cycle, it becomes 1 turn. So now we see that there's still 3 grasses cut and 72 grasses remaining on turn 2. And so when we hit next, we expect mower 1 to go in one of these directions depending on our algorithm. And our algorithm is one that all the mowers are trying to go to one location, and once a mower hits that location, we'll pick another random location based on density around the grass, and then it'll try to go there. So you'll see this more in action as I continue on this simulation. So when I hit next, you see that mower 1 has moved 1 to the right, mower 2 has moved 1 to the right, and mower 3 has moved 1 up. So now puppy 1 will get pulled, and we see that it stays, and puppy 2 will also stay. Alright, so then mower 1, what it does next depends on what it knows. So it knows that there's still a bunch of uncut grass here, and so when we hit next, it does a scan. So it's scanning a grass, and it sees, yep, well, there's 1 crater here, you can see it here, up here, and then 1 empty next to that. Mower 2 also scans, and then mower 3 scans as well. And then puppy 1 stays, and puppy 2 decides to jump. So puppy 2 decided to jump 1, 0, 1, 2, 3, 4, 5, 6, and 1, 0, 1, 2, 3. So now it's next to mower 2. So since it jumped after this, More2 in its own database thinks that it's all grass, so it may or may not hit this puppy. If it does hit this puppy, it should stall. So we go next. More1 decides to go 2 above, and this makes sense because More1 was initially here and it saw that there was an there was a grass to cut here, and More3 was standing here. And since More3 did a scan out here, it knows that More1 also now knows that there's a grass to cut here, so that's why it jumped 2. So this is for our purpose to be more efficient with each turn. So now More2 decides to jump over here. So we can see it should be, all the more should be going around the top left area. So More3, yep, goes here. Puppy 1 jumps. Puppy 2 does not jump, it stays. More1 scans, More2 scans, More3 scans. So puppy 1 jumps back. Puppy 2, so then we go and see More1 jump diagonally 2 spaces. More2 goes 2 spaces to the left, and More3 goes 1 up. So then we continue this pattern until we see a stall. So puppy 1 is now jumped on. More1, what it should have done is print M3 stalled 3 turns. But we might see, so we see More1 should go over here. Well, it should, once it hit this more, they both should have been stalled. And since More3 was stalled, it's also stalled. And More2 tries to go up. More3 should not have moved, but in this case, we have that. So puppy 2. So I'm trying to get to a scenario where, okay, so More3 hit a puppy. So in this case, we see that More3 has stalled for 2 turns, and that's determined by this number here. So we continue on, and we see that the mowers all get into one location. And so when we fast forward, we see that we have only cut 23 grass and 52 grass were still remaining, and we have crashed lawnmower 2 and 3. So please, you can edit this file or add another file and run it on the command line here using this command, and we give you a jar here, so please use this jar, and that's how you run our app. So although we do have room for improvement, we can see that most of the functionality is there, and hopefully in the future we will fix this and deliver to the client a working solution. Thank you guys for listening.